Hello everyone, I am Sanjay Gupta. I have an overall experience of 8 plus years in IT industry, out of which 4 plus years in Couchbase. I work as a database administrator, managing Couchbase deployments across various Mavenir customers around the globe. Manoj, over to you.
Thank you, Sanjay. Hello, everyone. I am Manoj Sailanathan. I have an overall experience of 9 plus years in the IT industry, out of which 5 plus years of experience in Couchbase. I lead database administration of Couchbase, MySQL, and a few other database technologies for Mavenir customers around the globe. Sanjay, back to you.
Thank you, Manoj. Today, we are going to talk about scaling telco workloads with Couchbase and how Couchbase is used as a data store for various Mavenir products. Mavenir is a telecom software industry which creates software that supports various telecom features. Major telecom providers are customers of Mavenir. In today's session, we are going to talk about the Couchbase use cases across various Mavenir products like the Couchbase DB for storing subscriber profile data, Couchbase DB for session data, and Mavenir develop monitoring for Couchbase. The first section of this presentation is Couchbase DB for storing subscriber profile data. For storing subscriber profile data, we were using traditional RDBMS approach. With traditional RDBMS approach, we were seeing quite a few challenges and we have listed a few of them. The first one is the replication. The data replication between the geo-redundant sites would involve like external component, and there is no redundancy method if there is any failure with respect to the replication procedure. Next comes the scaling. In a traditional RDBMS databases, scaling is a challenge, and the vertical scaling is the only option with respect to RDBMS databases, and application impact with vertical scaling is inevitable. Next comes the performance. In RDBMS databases, data is basically the disk driven, and the data is cached if any application query hit to the database. And as the data is disk driven, the I/O operations on the RDBMS databases are proportionately high as well. So we have started using Couchbase database for storing the subscriber profile data. By using Couchbase, we were able to rectify the challenges like replication redundancy, scaling without any application impact, and performance improvement, which we will be discussing in the next slides. The first one is replication. For geo-redundancy, we use Couchbase native XTCR feature. With XTCR feature, we are able to completely mitigate the third-party components. With XTCR, if there is any HA incident, the replication redundancy is intelligently handled by Couchbase itself, which reduces the major overhead faced by the traditional RDBMS databases with respect to the geo-redundancy. Next comes the scaling. With respect to scaling, horizontal scaling is the preferred method while coming to Couchbase. And with horizontal scaling, we can scale the cluster without any application impact. With Cluster Manager Intelligence and SDK Intelligence, scaling horizontally will not introduce any application configuration changes as the new nodes added into the cluster automatically updated in the cluster map, and also the same is pushed to the application as well, which makes horizontal scaling completely transparent to the application. Next comes the performance. Couchbase follows first in-memory architecture, with which the Couchbase tries to accommodate as much as data it can accommodate in the memory within the RAM allocated per bucket. Whenever there is a data manipulation, once it is successful in the memory, Couchbase immediately acknowledges it back to the application, and at the same time, it sends the updated data to disk queues and the replication queues as well, which makes the data consistency stronger and improves the application's database transaction latency. The next module is on Couchbase DB for session data. Manoj, over to you.
Thank you, Sanjay. So the next use case that we're going to see is Couchbase DB as a data store for session data. So session data is nothing but the ongoing calls, users, session information, and notification data, etc. So the nature of the data varies as per the use cases. Session data documents are driven with TTL values. The TTL values varies from 1 hour to 24 hours. As the data is less critical and regenerative in nature, we use ephemeral bucket type, which is only in-memory data store for better performance. In case of multiple node failure in Couchbase cluster and with ephemeral bucket, it goes without saying that there will be a data loss. Since the data is automatically repopulated by the application, if it's missing in the database, makes the ephemeral bucket type much suitable for the session data. Okay, so one of the major issues that we faced in our deployments were the resource usage. So the architecture that was followed in the Mavenir deployment strategy is Couchbase cluster with 6 or more than 6 nodes will follow MDS architecture, where few nodes in the cluster would run with data index service and the remaining few nodes will run with data and query service. The cluster comprises of nodes with 8 vCPU and 32 gig RAM. With this configuration, when Couchbase cluster is scaled to 50 plus nodes, the major challenges was that beam.smp process, which is the cluster manager, was consuming up to 50% of the CPU, and it's per node. That is 4 core per node. Overall CPU usage across the cluster hit 80 to 90%, even with just 50% of the actual estimated amount of traffic hit to the database. At the same time, since the index and the data service were co-located, we were able to allocate 65% of the memory to data service and 15% of the memory to index service. That being the case, as the data grows, the index RAM usage was proportionately growing as well, and it was reaching almost 100% of the index RAM quota allocated. And there were quite an amount of RAM quota which we were not able to allocate from the nodes which were running data and query services, because the index service doesn't run on those nodes. Allocating from those nodes is impossible. So we worked with Couchbase and we came up with the re-architecture of the Couchbase deployments. With these challenges in place, as per the Couchbase's recommendation, where the configuration goes as shown in the picture. In the cluster, it comprises, if it is comprising of 12 or more nodes, then the MDS architecture followed in the cluster will have 60% of the nodes running with data service and 40% of the nodes running with data and index and query service. Also, the VM flavor configuration was changed from 8 vCPU to 16 vCPU and 32 gig RAM to 96 gig RAM. With this architecture redesign, the number of nodes that were deployed earlier were reduced by 50%, as the CPU configuration was changed from 8 vCPU to 16 vCPU, and the same with the RAM. The challenges that were before the architecture redesign were rectified after the architecture redesign. The CPU usage of the cluster manager reduced from an average of 4 core usage to an average of 1 core usage. Since the data service and index service segregated and running on different nodes, the RAM allocation for these services became independent as well. Thus, we were able to allocate 80% of the total RAM for the data service in the data nodes, and we were able to allocate 80% of the RAM to index service in the index nodes. So that gave extra headroom for the indexes and the problems that we were facing with the index growing up to using the 100% of the RAM quota allocated was also resolved. Overall, the performance of the cluster improved, leading to a much stable and reliable Couchbase cluster with 100% of the estimated traffic hitting the database. So the next session is about Mavenir developed monitoring for Couchbase. Sanjay, over to you.
Yeah, thank you, Manoj. As part of Mavenir developed monitoring, we are going to talk about admin monitoring framework. As part of admin monitoring framework, the key features are like the cluster nodes monitoring, the node failure detection, the node recovery, monitoring indexes, and admin high availability. The admin nodes continuously monitors the nodes present in the cluster. If there is a node failure detected, admin detects the node failure and fails over the node. Once the node is back online at the expected state, admin recovers the node and rebalances the cluster. And admin continuously monitors the indexes present in the cluster as well. It captures the index definitions once the admin monitoring service is initiated. If any index node goes down and comes removed from the cluster and it is added back to the cluster, the admin framework is intelligent enough to shuffle the indexes back to the node which was removed earlier. And this is one of the use case with respect to monitoring indexes in the cluster. And also, as we said, admin has high availability feature also. The admin nodes basically works in the fashion of active and standby. If the active admin goes down, standby admin comes up as active and starts monitoring the cluster. A single admin active standby pair is not only restricted to monitor a single cluster. A single active and standby admin pair can monitor a multiple database clusters as well. Next, we will talk about the CRDL admin nodes active standby flows, and it will have a various flow states. As we talked earlier, the admin works in active and standby fashion. The first one is active admin and the standby admin both are up. And the next one would be when the standby admin goes down, the active admin monitors the cluster seamlessly without any hindrance. If the active admin comes down, the standby admin gets promoted as active and it will start monitoring the cluster. Once the previous active admin comes up, it becomes a new standby admin. Next, we will talk about the cluster monitoring flow. As part of cluster monitoring flow, the first step is to select the source node from the list of IPs configured in the config file. Once the source node is selected, by doing a connection test to bucket configured in the config file. The node which qualifies the connection test first will be considered as a source node. Once the source node is selected, using Couchbase CLI, admin will fetch the complete state of the cluster nodes. For each IP in the config file, the monitoring script will process the state to decide whether the node is healthy or not. And depending upon the states of the node, respective action will be taken by the CRDL admin to maintain the cluster HA. This is an overall monitoring flow on the Couchbase cluster by the CRDL monitoring framework. As we are reaching the end of presentation, if there are any questions, we are ready to clarify them. We would like to thank everyone for attending the session. Thank you very much.